Hi, this is Synthchaser, and today we're going to be repairing Bobby's ARP String Ensemble. So the ARP Solina String Ensemble is a classic string instrument that you've heard on lots of albums from the 70s. It's a polyphonic string synthesizer. It features 4 string voices and 2 bass voices. So this was manufactured by a company called Eminent Organ Company in Holland. And it was originally sold as the Solina String Ensemble. Then the American manufacturer ARP picked it up, and they had them manufactured, and they rebranded them as the ARP String Ensemble. So where it says ARP String Ensemble, these are actually just stickers over the original Eminent Solina silk screening. So let's turn this on. We select our voices, and there's viola, violin, trumpet. It switches. Contact needs to be clean there. There's the horn. And the reason that this is in for repair is because the bass voices have some noise issue. So I engage that, and it makes noise. The notes still play, but when the notes decay, it goes back to this noise. Same with the contrabass, the lower bass voice. So there's 3 revisions of string ensembles. Revision 1, this is a revision 2, and we can tell because it's got the steel frame and the modulation button. The modulation, I'll show you. It changes the sound. So the revision 1 did not have this modulation button. So if you have one, either an ARP String Ensemble or Solina String Ensemble, just with a solid block here, that is a revision 1. This is a revision 2. It has the modulation button, and it's built into this really heavy-duty steel frame. The thing weighs about 50 or 60 pounds, and it's kind of cumbersome to get out of its case. So it sits in a little plywood case. This has already been taken out of the plywood case. The revision 3 is less common. Instead of having a steel frame, it has a less discrete circuitry, and the circuit boards are just mounted inside the board, the fiber board case. So I'm going to show you the main problem with these is power supplies. The power supply is very underspec'd, and I'll open it up and show you the power supply, what we're going to be doing to rebuild the power supply, and why we need to. So to service this, there's boards on the back. So this is the bass voicing board. This is where the problem for these notes, the low notes, are going to be. And then underneath, if you want to come back around, we tilt it up, and then we can, I'm going to unplug it. And then we can get access. Basically, there's 2 layers of circuit boards under here, and these little trays of circuit boards fold down. They're held in by 2 screws, one here on the left, and one here on the right. So this gives us access to our first layer of circuit boards. To get to the next layer of circuit boards, we would unscrew here and here. So I'm going to show you the power supply and give you a brief rundown of what we're going to be doing here. And I'll be back in just a moment. So the power supply of the Solina String Ensemble is actually split across many different circuit boards. So if you look here on the schematic, you'll see there's a lot of different voltage rails, and it says source, so control circuit on top here. Means that voltage is derived on the control circuit board, which is this one right here. This minus 15 is coming from the gate circuits. The gate circuits is in that second tray, which we haven't folded down yet to get to. There's the negative 9 volt rail is coming from the master oscillator board. This is the master oscillator. You see the adjustable tuning coil. And then the rest of them are coming from the power supply board, which is this one. And if you'll notice on the power supply board, there are no ICs. There's no voltage regulators. This is an unregulated power supply. It generates these different voltages using resistors and voltage dividers. So there is a lot of current going through these resistors. It generates a lot of heat. You see they have ceramic standoffs. This is a revision 2, and the revision 2, they spec'd it, the resistors, a lot better. The revision 1, the resistors were really under-spec'd, and most of these power resistors, you could see, scorching on the circuit boards, and like for this one, the wire harness above it where this tray folds up to would be scorched, and the plastic insulation on the wires would be melted. So the power resistors were and are under-spec'd. And actually on this one, it's really hard to see, but this is the one that regulates the plus 25, or not regulates, this is the plus 25 rail, and it's kind of hard to see. Let me see if I can shine some light down there. But this resistor is actually bulging, so this is definitely something that we need to replace. The other issue with the power supplies is they use underrated capacitors. So you see the big filter caps here. They are rated 25 volts. Well, we have 29 volts coming into them. So this is just severely underrated. There's usually scorching on these. The revision ones, all these types of resistors, the paints are flaking off, makes it hard to see what value they even were to begin with. Also, this bridge rectifier here is also, even though it looks big and heavy duty, it's actually really underrated. So I have a kit that I sell in my store on synthchaser.com that has the components to replace all the capacitors, all the bridge rectifier, and all the power resistors for all of the power supply. So not just the part on the power supply board, but also the control circuit, the master oscillator, and the gate circuit, which is on the other board. This kit includes capacitors that are much higher rated. So we use a much higher voltage rating, pretty much as high as will actually fit there physically. And I'm going to show you this kit installed in Bobby's Solina here. So the kit also includes a new bridge rectifier and all new power resistors that are rated 2 to 4 times higher wattage than the ones originally in this. And they're going to dissipate heat a lot better. They're metal oxide resistors, and they're going to perform a lot better than what's in here. And the power supply, you can't really mess around with the power supply of a vintage synthesizer, particularly an unregulated one, because like this synthesizer has lots of chips in it that are just not available anymore. Like these SAJ 410 divider chips. This one uses an M087 top octave generator. All these chips are obsolete. The gate circuits use transistor arrays that you can't get anymore. So you really need to protect those IC chips against fluctuations in voltages that will destroy them. And while the power supply isn't regulated, replacing these capacitors, 40-year-old, this capacitor was made in October 1976. This is actually newer than some of the ones. I've replaced ones that had manufacture dates of 1973. And these capacitors dry out. They don't perform as well as they should. Plus, they were underrated to begin with. So if you own one of these, even if it's working, it should be pretty much a mandatory maintenance thing to recap your power supply, and upgrading those power resistors as well is very helpful. That will protect your investment, and the synthesizer will perform better and it'll last longer. So I am going to replace the components on the power supply, the control circuit, and the master oscillator board here, and then I'm going to show you what they look like installed. So I'll be back in just a moment. So we've got the components off of the boards in this tray that we're modifying. We've taken pretty much everything off the power supply board, with the exception of a couple quarter-watt resistors, which here are appropriately spec'd. On revision 1, they used eighth-watt resistors for these things, and in that case, they all need to be changed. And there's a diode here, which just creates a 0.7 volt drop, and that's the way that they do the 9 versus the 8.3 volt rails. There was a resistor here that was bulging, and this is the resistor right here. Kind of hard to see there, and it's a 150 ohm resistor, and it's measuring 281. So that's pretty badly out of spec, and we don't even know what it would do if it got to some heat through it as well. So that's not good. We've taken the capacitors and power resistors off the control board. There's a little pile of stuff we've taken off. And on the master oscillator, we're only changing the capacitor. Now there are a power resistor, and in many cases, if I can flip this over, there's one on the bottom there too. And these values are selected at the factory, so it's not something that that can be included in a kit, since we don't know what value it's going to be. So now we're going to put the new parts in, and I'll show you what it looks like once those are in. So we've finished changing the components on the first tray. So this is the rebuilt power supply, and some of you looking at this are going to go, "Oh, you're so cheap. Why'd you use radial capacitors to replace some of the axial capacitors?" And this was actually done not as a cost concern, but as a performance concern. The fact is that the presently available radial capacitors are much, much better than the axial capacitors. So in a high temperature, high ripple current situation like the power supply, it's worth retrofitting the radial capacitors in place of the axial capacitors. So here's the large filter caps. They were 25 volt, and now they are 50 volt. Same with this 2200. This one had to be retrofit to put a radial in, and the little ones there too. And see the power resistors. Those larger ones are 3-watt resistors, where there were 1 watt before, and the smaller ones are 1-watt resistor, where there was quarter or half watt before. So over here on the control board, control circuit board, we've replaced the 4 resistors and 3 capacitors that are used in the power supply section of that board. And then on the master oscillator board, we replaced the main filter capacitor there. And when I was taking these off and looking at them, so this was the filter capacitor, 25 volt 4700, and I don't know if you can hear it, but there's actually something rattling around in there. So this is way past its prime. And then I also found some components that I had removed from one of the Revision 1 Solinas that I repaired recently. This capacitor is actually charred. The bridge rectifier is burnt. And the resistors took so much heat that the coating came off and you can't even see what value they were supposed to be. So the next step is there's some components of the power supply in the gate circuit board, which is in the second tray. So we're going to open that up and take a look at what that looks like. So in this next tray, this is the gate board. And basically, it has one capacitor here which controls the sustain for each note that you play on the keyboard. There's also a bunch of TDA 0470 transistor arrays that control the gating. So on the ARP Omni, which is the descendant of this keyboard, they use tantalum capacitors here, which would short out all the time. But they used electrolytics on the Solina, and they actually hold out fairly well. However, there is a component to the power supply on this board. It's like I said, it's spread across all the boards. And that's actually the only part of this power supply that's regulated. This is a transistor regulated minus 15 volt supply. So there's a 220 microfarad capacitor here, and then there's actually a little trimmer that lets you adjust calibrate the voltage. So this is one that we will change out as well, because this is part of the power supply. There are no power resistors here because it's not using a divide down approach, resistor dividers. It's doing it with a transistor. So there is no power resistor that needs to be changed on this board. Finally, we've turned the string ensemble around, and this board here is the bass board. So this is the board that controls the bass, the monophonic bass, the low notes. What do they call it? They call it the contra and cello. So there's only 20 notes out of the 49 keys on the keyboard that will play these notes, the low 20. And internally, this board does divide down to a different voltage that's not listed as one of the rails because it's only used on this board. It's a minus 5 volt, and you see the power resistor there that's responsible for that. Usually, I see these boards are pretty scorched at that point. So we're going to replace the 2 power resistors there and the capacitors associated with that. And since we know that Bobby's having some issues with the bass voicing on his synth, we're also going to replace the 2 capacitors that are used by the clipping circuit. So these 4 blue capacitors, and the 2 power resistors. And these other ones are just used for gating the bass notes, so they are probably okay. So I'll be right back and show you what that looks like when it's done. But the way that we get the bass board off to access the back is there's some screws here and some screws here, and then the whole back panel will come off. We can fold it down or up, and we can get to desolder these components and solder the new ones in. So I'll show you what it looks like when it's complete. We've changed the components out on the bass board. So these 2 resistors here and the 4 capacitors. In this situation, the axial ones are fine. It's not a very high load board. When I was taking them off, I noticed on the, I don't know if you're going to be able to see this, but you can see, hopefully you can see the corrosion there. This 22 microfarad capacitor had leaked electrolyte, and there's some corrosion on the lead from it. You can kind of see on the side where it leaked. So let's turn this around and make sure that we're no worse off than we were before we started the power supply rebuild. So I'll be right back and we'll test it out. We've turned it around and plugged it back in. And now let's fire it up and make sure that everything that was working before is still working. I've cleaned the trumpet switch, so hopefully it'll engage this time. So, viola, violin, trumpet, horn. And now let's check out the bass voices. I'm not totally confident that the just a recap of this is going to resolve that problem, but let's check it out. No. No. So we have some troubleshooting to do on the baseboard, and we'll figure out what's causing that problem and update you on the progress. So I'm back, and I poked around with the oscilloscope and found the problem was a bad op-amp, this suppression trigger op-amp. This one right here was bad. For good measure, I replaced the other op-amp, the clipping op-amp, even though I think it was okay. I put them in sockets so they'll be easy to change if they fail again. One thing to note, this was the original op-amp. It's a LM709, and those are obsolete. They're not made anymore. They're in a 14-pin package. The 741 is a marginally better drop-in replacement for the LM709. However, it's no longer made in a 14-pin package. The interesting thing is, 6 of those pins are not used, so you can actually use an 8-pin 741 to replace a 14-pin 709 or 741, which is what we've done here. So I'll go ahead and turn the keyboard around and show you the finished product. So I've turned it around, and I'll show you that everything's working great. So we have our string voices. The switch is still a little bit dirty, so I'll have to go back and take care of that. And now, this is where we had problems before, the bass voices. When I would engage it, it would make a low rumbling noise. Now I release and it's fine. Also, the low note priority seems to be working now, whereas it didn't before. We can do the 1 octave down. And it's working great. So I hope you enjoy it, Bobby, and that you put it back to good use, making good music. So this is Synthchaser. Thanks for watching.